Hello everyone. Thanks a lot, Christian, for your presentation. You actually helped me a lot establish a lot of the baseline of what we're gonna talk about, and I believe I'll refer to your talk at a couple of points in mind. So my name is Artem, or Artem in Russian, and I'm a team lead of the agent platform team at Zencoder, a coding agent AI startup. And today I wanted to talk about how software agents coordinate to solve complex tasks. The working title of this talk was actually more like how to build a multi-agent system for your software development using tools you probably have at home, but it was too long. Corporate cut it. Okay, so a couple of words about Zencoder, why we have actually an opinion on this matter and why it might or might not make sense to listen to us. We're building an industry-leading coding agent platform. We're providing coding and custom agents as in our plugin for VS Code and JetBrains. We have an early access offering of autonomous agents in CI. We can provide you with a multi-repo context for the organizations that have multiple repositories with different microservices, back and front and whatnot. We can actually provide the agent with the context across all these repositories. We have multiple integrations with the tools you already use, Jira, GitHub, other repository providers, Slack, whatnot. And yeah, they asked me to put a cool fact about us. I didn't have one until recently, but so I'll share it now. Just an hour ago, our PM messaged me and said he used Zencoder to set up local dev environment for a project, code a feature, fix some bugs, fix some CI checks only in an hour and a half. I think that's pretty cool for a product manager who didn't have any experience working on this product before that. Okay, and we also use, I have to admit, we use the Zencode as a verb internally. So we can say this product manager Zencoded a feature. And so, as I mentioned, thanks a lot to Christian for actually establishing a baseline and making sure we're all on the same page of what agents are, but I just want to give you another refresher. So, as you know, the usual LLMs is just one single request that goes to an LLM, gives some output. When we go to the agent, we get an agentic loop, a feedback loop that lets the LLM reason, lets it call tools, lets it feeds the result of the tools back into the LLM, and this feedback loop leads to better context that goes to LLM, better results, and lets it interact with the environment, giving us a much more powerful tool. Some examples of what these kind of tools can do in the software development world. Most of them coming once again from a product. Well, you got your base coding agent that can write features, fix bugs, do refactor, whatever else you ask it to do. You can have a review agent that once again uses tools to analyze the code in your PRs and to actually submit comments on your GitHub. That a testing agent can once again reason about your code and call Playwright to record how your app actually works and generate tests, etc. And why, if you can see here that once again, as Christian said, all these agents are very domain-specific agent. So why would you need domain-specific agents, and why sometimes one single domain-specific agent isn't enough? Well, there are several quite obvious limitations that wouldn't allow us to use a generic agent that can do all your work for you, whatever you ask it, that would be able to just take a huge task, as a dev would do everything you need, analyze it, test it, whatnot. First of all, we got the limited context window. It's very hard to hold a huge context in memory. Like, you know, software projects can be enormous. They can span multiple repos. They can have mono repos consisting of thousands, I don't know, hundreds of thousands of files. You can have different project setups. It's very hard to reason about in a single context window. And also the coding agents of today, they have to complete the task, they have to actually have huge trajectories. They can call they can execute 10, 20, 50 tool calls. It's very hard to, once again, to fit into the context windows of the models of today. And also, each agent requires different prompts, different tools, different types of context engineering, everything else. So in order to work on a huge task, in order to achieve some very good result, you need to make agents collaborate. And today I wanted to talk about a very specific way that once again you can make agents collaborate, once again with the existing tools without fancy agentic frameworks, without anything. And this is running agents in CI, and how you can use this to split up work between multiple agents and automate it, and some patterns that you can use in your multi-agent systems. Like that. That's what we do here at Zen. That's what we do in Zencoder. You have some external trigger that triggers your CI action, like a GitHub action, whatnot. And in this action, you actually run some kind of an agent that has access to your development environment, because it's running in CI. You already got this setup, right? You got your checks, you got your lints, you got your tests, build, scripts, pre-commits, whatever you guys use. And with this environment, the LLM can interact with your tools exactly in the same way as a developer would do, or as a regular check will do. And the result of this can be a PR that you can merge in your code, can be some comments in the PR that you or someone else created, and anything else. And this is a very powerful foundation for building multi-agent autonomous agent systems. So what else can you do here? What can you do here? For example, let's say we have a ticket and we want our autonomous multi-agent system to work on that ticket, but we have a problem. We have 3 repositories. Each of them has their own CI. Let's say we have backend in our project, we have frontend, we have mobile, and we have a single ticket that, let's say, implement a feature across all of our tech stack. How do we understand that which CI agent out of those 3 repositories to call? Or maybe the change needs to be done in several repositories. We can, first of all, just using some kind of a automation like a webhook, send the task to a planner agent that will analyze the task description. It can have access to the repository context. It can be basically just a list of your repos with some information what is in each of them, or it can be a code search that will allow it to understand better something that is not present in this information. It then can split the task into several subtasks. It can call the coding agent in the backend repo, in parallel the coding agent in the frontend repo, and like if you have a mobile application, it can also code a mobile application for you. The same can be done if you have a mono repo. Obviously, you can have 3 agents working in parallel, submitting 3 PRs. And then each of them will do its work, and you'll just have a full feature coded in parallel. Yeah, and then what happens with each of those PRs. As you probably know, the agents don't always output the best code out there. They make errors, they sometimes don't follow the best practices, they can do some weird stuff that will make your company lose a lot of money, which we don't want, right? And what we can do is we can have the coding agent submit a PR, then once again call a via GitHub action. We have simple automation that will have in our repositories, run a review agent that will review this PR, and this actually can improve the quality, because having a second pass, even of the same LLM, review the code can really point out the deficiencies in the original version. Then the review agent will leave comments, and we can press the changes requested button. We can also leave some comments on our own. We can, I don't know, pick up the CI checks, and then it all goes back to the start. So there's a loop, a larger feedback loop. You know, agents are already feedback loops. So it's a feedback loop of feedback loops, if you will. That will actually, after a couple of iterations, can really improve the quality of our code. A small detail that, as you see, I put changes requested here, because we don't really want this loop to become infinite. We want to stop this at some time, so I keep on here that at least now this is kind of a human in the loop thing, that for now it's still best to have the human actually decide if the requested changes need to be sent to the follow-up agent to fix them and go on. So this, we can see two patterns emerging here. They are very simple. They are more closer to the fixed workflow patterns than to more advanced stuff with agents calling agents, deciding when to call agents on their own. But oftentimes the simple stuff works the best. We can have a planner agent actually split and route the work between multiple agents. You don't have just to use it to decide which repository a Jira task needs to be fixed in. You can also have, if you, for example, build in a documentation or rebuild in a documentation for a huge project, then you can have the router split the task of building documentation into several sub areas and say, hey, you go to this part of the repo, you document this, you go to this part of the repo, you document this, etc., etc. And then we can add another stage to merge these documentations to generate the final doc. And the second pattern that we've seen, once again, is a pipeline or a sequential workflow pattern with a simple agent handoffs. Once again, this is definitely not the only use case we can see for this. We can start from requirements and have the agents drill down from the business requirements to the technical requirements, then next agents picking up the technical requirements and build an acceptance test from it, then the next agent actually writing the code until the acceptance test passed, etc. And I'm pretty sure you can come up with a lot of examples on your own. Yeah, so just two key insights. You notice I didn't have a lot of insights, so I had to make the fonts really large and the space really huge. So reuse stuff you already have. That's down to one insight now. If you have automations in your business, in your code area, if you have GitHub Actions, Bitbucket pipelines, webhooks, Zapier, whatever else, Jira automations running, you can use this to connect agents. And the second, run agents in existing environments. Once again, you have CI workers, you can run agents in the CI workers. You can you use code spaces or some other development environment as a service, as they call it now. You can run the agents there. And by combining these two, you can build multi-agent tools with a multi-agent system with the stuff you have at home. And you probably already have an idea of how this multi-agent system can help us developers. Well, it's basically the next level, because we already see coding agents giving a huge productivity boost to a quite large part of the developing the world of development. And when you go to the collaborative system, you can basically solve more complex tasks. You can solve those tasks autonomously, automating your tedious work. You don't have to. You can have a multi-agent system collaborate to fix a dependency, a security issue over all your code base, or to perform a huge language version, framework version upgrade. You can have all this running in parallel, like multiply, scaling your productivity from 10x, 100x, and hopefully in the future. Probably we're not there yet. And we have, obviously, with the context tools that we make available for those multi-agentic systems, like to make them actually collaborate over multiple repos. You don't have to switch context between repos yourself, and just focus on higher level tasks. And the next question is, how does this impact us in the other way? I'd like to talk about the future a bit, because all those systems are evolving rapidly, and the fact no one knows which no one can tell you which impact we'll have. We're building coding agents, and we have no idea. But what we see now, what we see in emerging, every dev becomes effectively a team lead, of leading a small team of coding agents that can collaborate within that, and you will be building agent pipelines to make you and your team work more efficiently. You will use a lot of AI tooling. You will use probably something more advanced, going more into the autonomous territory than what we have now. I think a lot of, well, there's codecs, there's cursor background agents, and there's obviously our Zen Agents for CI that you can request early access now to actually, and we can actually show you how it's all built. So please contact us. And I guess that's it for my talk. Thank you for your attention. Our team will be here to network, so please, if you have any questions about the product and anything you want to talk about, please come over and connect. We'll be happy to see you.
Yeah, thank you.